All right, so what I've got is the PDF over here. Kind of hard for me to type on the PDF, so I'm going to type over here my answers as to what we're working through here. But number one, it says, state the law of conservation of energy. Well, what that basically says, and in a nutshell, I don't expect you to get 100% perfect. What I do expect you to understand is that energy cannot be created, lost, or destroyed. It can only change form. Now, that's where we're at essentially with what conservation of energy. What it means is that we can't lose it. It's just simply going to, it can't be created. We can't all of a sudden, ta-da, there's energy. We can only change its form, as we talked about in our notes today. Okay, 200 kilogram boulder is 1,000 meters above the ground. What is potential energy when it's 1,000 meters above the ground? So this is actually 2A. How about we go 2A? And what is potential energy? Well, that is potential energy equals mgh. So I'm going to say the potential energy here would be equal to the mass, which is 200, times gravity, which is 10, times its height, which is 1,000. So we would then say the potential energy is going to be a big number. 2 times 1 is 2. And then we're going to add 1, 2, 3, 4, 5, 6 zeros at the end of it. 1, 2, 3, 4, 5, 6 joules. Let me do something here, make this a little easier. There we go. So I like the way that looks a little better. So our answer was 2 million joules there for 2A. To be or not to be. What is the kinetic energy when it's 1,000 meters above the ground? Well, kinetic energy, this is a little bit of a trick question, but it's not really meant to be. It's kind of meant to be really easy. So kinetic energy is the mass. It has mass. It's got 200 kilograms, but it doesn't have a velocity. So what we'd essentially be saying here then is if it doesn't come to you right away, some of you are saying, why am I writing this down, Mr. Kimball? It doesn't have mass, and I get that. But let's look at it here mathematically. Just amuse me here for a second. And its velocity is 0 squared. So anything times 0 is equal to 0. So its kinetic energy is 0 joules because it's not moving. So some of you might have right away said kinetic energy equals 0 because it's not moving, and that'd be fine. There's nothing wrong with that. 2C. The boulder begins to fall. What is its potential energy when it's 500 meters above the ground? So potential energy is still mgh. The potential energy in this case then is still 200 times gravity, but now its height is no longer 1,000, it is 500. So the potential energy, if we take 2 times 1, we get 2. 2 times 5 is 10. And then I'm going to put 1, 2, 3, 4, 5 zeros after it. 1, 2, 3, 4, 5 zeros after it, which turns out to be 1 million joules. The second part of this question says, where did the lost potential energy go? Because remember, we initially had 2 million joules. We're now down to 1 million joules. So the question becomes, where did the missing energy? We got 1 million joules that's missing. Where did it go? Well, the lost, I'm going to put this in parentheses because we're kind of making fun of the word lost here. It's not really lost. It has been converted into kinetic energy. Why? Because it's moving now. How much kinetic energy? The kinetic energy has to be equal to everything that's missing. It has to go somewhere. So we got 1 million potential energy joules missing. All of that energy has now gone into kinetic energy. So it has 1 million joules of kinetic energy. All right, 2D. What is the kinetic energy of the boulder when it's fallen 500 meters? Well, we just did that one. I'll write it down here again. All right, if we look at it this way, the kinetic energy, I'm going to do this mathematically here without numbers, is the potential energy initially minus the potential energy of where it was at the end, at the final. And that was how I got the 2 million minus the 1 mil. I'm just writing mil instead of writing all the zeros out. So that means the kinetic energy, as we said, was 1 million joules. Well, hey, I'm going to stop right there. Right there is 3, 4, 5, and 6. So you've got about 10 total problems, if you count A, B, and C, left for you to work out there on your own. Hey, I hope that was beneficial for you guys. I'll catch you on the flip side.